So how am I going to get these in? This is where the fun really begins more with this puzzle. The way that I'm going to manage something like this is it's going to be an extension of corner edge swapping. So you may have already guessed that with cuboid strategy, it doesn't matter how many layers down you go. I can extend layer after layer after layer after layer, and all it means is just continuing to do cuboid strategy with each layer by doing by just going from one layer to the next. Even if I did 3x3s. So if you take a look at this. Now, as you may have guessed, the more layers we add, it really doesn't matter. The strategy is the same. And that's basically the archetypic strategy here, that it doesn't matter how many layers I have. This is a 3x3x2, and there's a process by which you can swap corners. And it doesn't matter how far up you go. You can do this with a 3x3x4, 3x3x5, 6, even this guy over here, 3x3x7. Nice, interesting, shape-shifting 3x3x7. Made by Sigurd Wedel. This is really well put together, very nice, fully functional, but and accidentally scrambled. Oh, that's pretty cool. But basically, it's done the same strategy. Of course, you have to get it back to the cuboid form, and then once you do that, you just follow it sequentially, and you solve 3x3x3x3x3x3 all the way down. Well, I'm actually going to take that concept into the next dimension. Got it back. And anyway, so this is just a series of sequential 3x2s all the way down. What I'm going to do is the same strategy across. So how do I solve it across when there's all these layers? Well, it's the same way. I just have to change my perspective. And it's always the same. There's a middle and two well, not really a middle. There's an edge and two corners. And what I'm going to be doing is edge swapping and corner swapping. And the algorithm is the same. 2R, U, 2R, UI, 2R. We'll bring it from the top to the bottom. Move it over here. 2R, UI, 2R, U, 2R. What I effectively did was edge swapped. So that's really what that is. And then, of course, there are middle swaps. Adjacent middle swaps and opposite middle swaps. Adjacent middle swap. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. So, ta-da. All right, so it's really the same concept here. So let's take this big bow hunk of a thing, and here's what I'm going to do. First thing I'm going to do is I'm going to start with the center, and I'm going to say this is my center, and what surrounds, or rather this is my edge, and what surrounds that are my corners. I'm only going to focus on these. The rest are going to be thought of as extensions. So I'm just going to be doing based on these. Now the organization will be exactly the same. The parity of this puzzle has not been broken. The parity is the same, and the algorithms, the permutations, which I guess is really what parity is talking about, the number of permutations, is no different from here. I just have to extend it outwards. So what I would do first is I'm looking to see two corners that are placed. What I used to call the sandwich before it was causing a lot of confusion is the what the heck I meant. So I'm looking to see which two corners are in. If I don't see two corners are in, right over here. So two corners are in over here. So this is my quote sandwich. This is what I have that I'm going to be moving off to the side. So this moves off to the left. And I'm going to do an adjacent corner swap, which is all of these and all of these, so that I can move this blue one to here. Now, oftentimes what happens with this puzzle is that these on block are over here. If that's the case, if doing a corner swap is not going to put a blue one here because the blue one is here, then I look at this whole set as an edge, this whole set as an edge, this as a corner, and I do an adjacent edge swap to bring it over here. I may be able to show you what I mean by the next layer, but basically it's going to be the same algorithm, but this is going to be my R. So 2R, U, 2R, UI, 2R, do a UI, do a D, top and bottom basically, 2R, UI, 2R, U, and 2R. Now if I do the algorithm, through the magic of algorithms, I will not mess this side up over here. I'll move this back, and there you have it. Two corners, two corners, two corners. So now what I have to do is I just have to do middle or edge swaps. So if I say swap these two, this blue one will be where it needs to be over here. So now I'm just going to do an adjacent middle swap. It's the same thing, but this is my 2R. So 2R, U, 2R, U, 2R, 2U, 2R, 2U, stay together, 2R, U, 2R, UI, do not finger trick this one, 2R. Swapped over here. Now bear in mind, it created misplacement of sides over here. I'm going to say I used to call that parity, created parity, but to be absolutely honest with you, I don't really think that's actually parity. It's more placement issues. At some point I'm going to go into what I've been meaning by parity versus fallacy of false equivocation versus 3-cycle issues. It's not all the same, although sometimes we use the same terminology. But now I have to switch these two. Let's put it to the side where the misplacement happened, and then we'll go ahead and swap these two. Same algorithm. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Great fun. So good, 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 good. So we've isolated those. So now the next step, once we've done that, we could actually see if they actually correlate with where they're supposed to be. This isn't, this is, so it's easy enough. Now we can look at all of these as edges and these as corners. So let's go ahead and place these where they're supposed to be. So this can come over to here. We don't really have to do that yet, but it might make things make more sense. So now I'm going to do this as 2R, and this will be my edge. 2R, 2U, 2R, 2U, 2R, 2U. Okay, it created misplacement over here. Now, should I just let that go or should I put that back in? I'm actually going to put that back in because it's easy enough to do. I'm going to hold it over here and do that quote parity algorithm, which you can use for parities, I suppose, and move these back here. And that's going to be the URF variant of that. So this is going to be my U over here, and then this will be my U over here, which will go, you want to go just in the middle of and just above the parity, or the misplacement. F to U to U. Then to F, bearing in mind this is our F here, to F, to R, to U. Okay, so that gets that back. Move it back over. Okay, so that gets that back. So everything is where it needs to be. So now we extend it out. We got these in. Now we need to get these in over here. So it's the same thing. Now the corners are these two, not this, not all of these. This whole thing en masse is the edge, all of these, and now we have to get corners in. Well, these two corners are in place. It doesn't look like a sandwich, it looks like a bar. These two aren't, so we're going to do the same thing. This is held to the left, and now this is my edge. These are my corners over here. This whole thing is the edge. But as you can see, this is blue, and I want to have an orange one over here so that I can create edges on both sides when I swap it. So the orange one is actually here. So what I need to do is I now need to look at this whole thing as an edge and do an edge swap, an adjacent edge swap to pull this orange side here, or this orange corner here, so I can do the corner swap here. So from time to time I look at just this as an edge, then this as an edge, so that's what I'm going to do. Adjacent edge swap to move this to here. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Okay, so that's exactly what that did. Now, instead of looking at all of this as the entire edge, just this, and these are corners. So I'm going to do a corner swap to move this orange over here to create the orange corners in place. So now this is my R, 2R, U, to R, UI, to R, turn, turn, to R, UI, to R, U, to R. A little bit of alignment issue there. And this moves back. Okay, so 2 oranges, 2 reds, 2 blues. We are cruising. Okay, so now what we want to do is we want to go ahead and do middle swaps. Now notice the corners aren't lined up where they're supposed to be, but that's okay. We can do that. We can fix that with edge swaps later. But now I'm going to move this to here to create an orange side, and this red will come over to here. So adjacent middle swaps, edge swaps rather, to our U, to our U, to R, to U, to R, to U, to R, U, to R, UI, to R. So, as anticipated, this is good. This is good. Now we do our edge swap, our opposite edge swaps, to R, to U, to R, to U, to R, to U. Okay, so we got it. We paired our edges and we're fine. Now, if you want to move things inappropriately, we can do that if you would like. So we'll do an opposite edge swap with this whole thing to move the green one in here. To R, to U, to R, to U, to R, to U. I don't worry about misplacement because I'm not working on these yet. So then we just do opposite edge for this, to R, U, to R, U, to R, to U, to R, to U, to R, U, to R. UI and to R. Okay, so all is right with the world. It's all in. So now what we have is we've converted this to a 3 by 3 by 6. And that's pretty much how we're going to solve it at this point. The way to do that is you've got the middles. I'm going to start off with the middle 2 over here. These 2 are complementary. These 2 are complementary. I'm just basically going to do this algorithm. And notice I just used the concept with these. I redefined what are my edges and my corners, and I was just fine. Apply this to any one of your cuboids, even this guy over here if you've got it, or the 5 by 5 by 4. So starting over here, I need to find the red and blue. Find it up over here. Do I see it? No. I'm going to move the whole layer as one. It's going to mess things up, but not so much. Blue and yellow. And this is it. So blue and orange rather. So this is going to move down to here with edge swapping over here, or corner swapping here, to our U, to our UI, to R. So we're good over here. So now we move on. Orange and green. Do we have one up here? We do, and this is the proper one because it gets flipped when it comes down. So, to our U, to our UI, to R. The interesting thing about Shapeways products, as opposed to mods, which I enjoyed both, is this was made to be this shape. This was made to turn. This is a bottom-up creation, which is fascinating that it can be done like that. Green and red, right over here, right in front of me. To our U, to our UI, to R, and finally red and blue. Right here, nope, we're wrong, red and blue. This is the correct red and blue right over here. To our U, to our UI, and 2R. Okay, so this layer is all solved, which means that its complementary layer above this is ready to go. And I'm doing the same methodology. I'm looking for two corners that are in. Do I have it? Do I have it? Nope. Yeah, I do, right here. So I'm just going to set this to where it's supposed to be. And now I'm going to move the green one here with a corner swap. 2R, U, 2R, UI, 2R, whole puzzle turns, 2R, UI, 2R, U, 2R. Fantastic. So, as predicted, all these corners are in. What I'm going to do is just put them in the proper side here. So all the corners will automatically get lined up. So really what I'm showing is it's one algorithm, just applying it in different strategies, which is fascinating about this. Now all I have to do is some opposite edge swaps to get these guys in. Well, not completely. So I can move the green one in anyway. 2R, 2U, 2R, 2U, 2R, 2U. Now if you decide to buy this puzzle and you decide to assemble it, use a very little amount of lubrication. What I did is I just sort of separated it here, put this CRC silicone spray, just squirted a little bit. That's all it took. All it took. And then it really loosened things up. You don't want it too loose because you don't want pieces popping. Adjacent swap. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, and 2R. Okay, and now we just have one more adjacent to go. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Movement of this puzzle is quite seamless. Okay, so now we have a middle here. We've eliminated an edge. But now every time we start to do our top to bottom switch or edge switching, we're going to create misplacement of sides over here. So now we're going to work on this layer down here. Green and red. Find the green and red up here, if it exists. Right here, and it's the correct one. So now we're dealing with this layer up here. 2R, U, 2R, UI, and 2R. So that's good, but as you can see, we have edge placement issues here, which means I just have to keep holding it over here. I'm going to move these together, red and blue. Can I get a red and blue? Nope. Okay. And if I don't have it, move on. Blue and orange. Thought I might have saw it here. Nope. Move on. Orange and green. Gotta give me something. Yep, right over here. Orange and green. Okay. 2R, U, 2R, UI, 2R. Alright, so that took care of that placement issue. And now we move on. How about blue? Well, we'll do this one. Red and blue, which is over here. 2R, U, 2R, UI, 2R. And lastly, blue and orange, which is here. 2R, U, 2R, UI, 2R. Fantastic. Now we just have everything in here. We just have to see corners are in. We got lucky. All the corners are in, so we just need to do edge swapping and edge placement. Let's swap these two. 2R, U, 2R, U, 2R, 2U, 2R, 2U, to R, U, to R, UI, to R. Alright, that's swapped here. Placement issue over here. No problems. Let's swap these two. To R, U, to R, U, to R, to U, to R, to U, to R, U, to R, UI, to R. Now just an opposite edge swap, and we're home. Let's put the edges where they're supposed to be. To R, to U, to R, to U, to R, to U. Okay, so these are all in. We have placement issues over here. Do we fix it now or do we wait? Doesn't matter. I kind of like fixing it now just to have it done. So to U, to R, to F, to U, to U, to F, to R, and to U. Okay, see? No worries. Now the last two layers to go, green and blue, or green and blue. Goes that color blindness. Orange and blue goes down here, to R, U, to R, UI, to R, that's in. Keep it held here so that we can deal with this placement issue. Green and orange, just one block over. To R, U, to R, UI, to R, we're good. Fix the placement. And now red and green, right here. To R, U, to R, UI, to R. And lastly, this guy over here. To R, U, to R, UI, to R. Step by step, inch by inch, getting it solved, putting it back in the conformation that it started with. Now the last layer, same thing. Do we have corners in? We don't, so let's do a swap. And it doesn't matter which one you do, you can do actually any one of them. So why don't we just randomly do a swap over here. This will come here, this will come here. And you might think, well, that's really not going to help too much. And you'd be right. So what I'm going to do is I'm going to do that anyway. Okay, so to R, U, to R, UI, to R, turn, turn, to R, UI, to R, U, to R, and this is turned back. Okay, so we created edges over here. So for the last time with this puzzle, we do another adjacent edge swap to move this to here and this to here. Now, I'm going to point something else out that you might not have noticed, which will become important for later puzzles. Because this will come here and this will come here, but this will also come over here to match with this red. And this will come here to match with what will be this green over here. So that's something else that happens. Anyway, to our U, to our UI, to R, turn, turn, to our UI, to our U, to R, and this is turned back. And now our opposite, or our edge swapping, let's go and swap this to here to get our green in, to our U, to our U, to R, to U, to R, to U, U, to R, UI, to R. And now we do one final adjacent edge swap, which is here. Didn't have a lot of edge placement issues towards the end. To R, to U, 2R, 2U, 2R, 2U, and it's done. The 6x7x7 or 7x7x6, however you want to call it, has been conquered. Now, this is probably as high as I need to go to demonstrate this kind of cuboid, because it doesn't matter how far out you go with this, it's still the same way. Just variate what you look at as edges and what you look at as corners. Edges, corners, edges, corners. It's the same strategy. Sometimes you have to move edges. What you thought was a corner, you have to look at it as an edge, then look at a corner again. So with that strategy, you should be able to solve any kind of big cube, whether it's this, or this, or this, or anything in between. So 6x7x7, you should be able to solve Tom's 6x6x7 when it comes out. You should be able to do any of those. So there you have it, from assembly to stickering to actually solving 6x7x7. Excellent puzzle. Highly recommend it. Thanks for watching.